All right. So, and do back where we left off yesterday, in that we're doing the task wrapper tests, and what we talked about last time was all the stuff about synchronization contexts. So the point is, we're trying to test configure await, and we need to have a custom synchronization context in order to do that, so that we can um, keep track of whether or not the configured uh, context capturing um, is honored. So let's do it. So we're going to need this synchronization context here. Just check some things real quick about all this stuff. Okay. Okay. So what can we do? Yeah. I'm just gonna try to walk through this, but it's so basic, and it seems to serve the purpose, so I don't see any real need to change this. All right, so what our synchronization context is going to do is say, hey, we're running everything on one thread. We can be asked to process stuff from many threads, so we need a way to keep track of all the stuff. These callbacks are what we're being asked to process. So we're going to keep track of all the stuff we've been asked to process um, in this concurrent queue, and then we will just have our one thread do the schedule method where it pulls stuff off the queue and processes it and waits for more stuff to show up in the queue. And the important aspect to this part is that we are setting the synchronization context in this thread to be ourselves. So anything that we are asked um, to schedule uh, is going to all have this as its context. And being that it has this as its context, it's running here, literally running here. Like the delegate that we got passed is being called right here. And so it's all only ever getting this context on this thread. And so we can do things like assert the same thread ID is being used and also assert that it is literally this synchronization context. So that's exactly what we're going to do. Now we have the mock synchronization context. Let's test it out. Um, configure await true. Let me just look here what I did. Yeah, okay. And we don't actually need to use that stuff up above either. We might need to use it. We'll see. But let's just do it. So our synchronization context is a new mock synchronization context. Um, synchronization context is set synchronization context. Okay, cool. Is this context? All right. And now what we should see here. Um, so if we, oh, this needs to be async as well. So now if we say await task.delay, um, configure await true, then when we get to here, this next line, so everything after this will have been sent to this synchronization context using I forget which, but one of these two methods. Um, and so it's going to then get processed in here. And so what we should see is that because this, which is this, is the synchronization context in the schedule method, then whatever after here being the delegate that got sent to us and put in the concurrent queue, all that stuff should see the exact same synchronization context. So what we should now be able to say is synchronization context current, um, whoops, current. So uh, our current context is that. And then we should be able to assert that is not null current context, and also assert our equal the synchronization context and the current context. So let's just run that, get our sanity check going, make sure we're on the right track. This all, like I said yesterday, this all is very new to me. Great. So clear weight, true. So I'm gonna put it to do real quick to make some other assertions. But I want to continue with the sanity check type stuff here. So we also need to try make sure that different behavior when we say false. So let's actually do that. So configure await false, and let's just do the same exact thing here. That false, and now what we should see are not equal. Let's run that. And that passes. Great. So we changed the one thing and we got the expected result that we're using a different synchronization context. So let's go back up to this one and do some additional assertions. And the thing I want to assert is that the correct thread ID is being used. So because that's what this synchronization context is doing. It's not like a magic thing or something that I'm assuming. It is, we've written the code to make that happen. So in addition to being in this synchronization context, we also expect that as a result, we are running on the thread that this synchronization context is talking about. So let's assert that. Assert our equal, our expected thread is synchronization context at thread ID, and the actual will be thread.current thread.manage thread ID. So let's just run that as well. Great, also passes. And so the thing is down here, we actually can't make that same assertion because nothing, maybe something does guarantee that we won't use that thread. So, oh shoot, is this disposable? Oh, no, let's try. Close, stop. Okay. So actually, I think that we can know that we won't get that thread ID. Yeah, interesting. Okay. So let me think about a few more things. So the thing I'm thinking about is, um, can I make this same the opposite assertion down here? So this is really what I'm thinking. Can I say are not equal? And I think 99 times out of 100 probably it's gonna pass. Because like the odds of me getting the same thread, getting that one exact thread are actually pretty low. But I'm thinking that that's actually a safe assertion because that thread is already dedicated to this synchronization. I don't mean like in any convention-based source. Like we have said, that thread, that's ours. We own it. No one else gets at it. Maybe that's what you can do. So new thread. Is there a way to get at the Particular, yeah, thread dot from ID or something from free. No. Um, huh. Um, I don't know. I'm actually gonna look this up too. So C sharp get the thread with a given ID. Let's see what we get. Thread ID from a thread. Provide a method to retrieve a native handle. Process ID. Processor ID. Interesting. Uh, yeah, I really don't see what thread pool gives us. Yeah. Kind of a nonsense question. I'm pretty sure it doesn't actually make sense. Um, Multiple threads calling the same objects. Thread safe calls using delegates as a method. Yeah, it was a nonsense question. Okay, that's okay then. I think we can actually um, make this assertion, and it's much safer actually than this assertion. So that's another good question. So what I'm thinking now, what I just said it's a much safer assertion, but I don't know that that's true. So what I'm thinking is it possible that when we say configure weight false, like it might continue on the captured context, it might not. Um, Like that's my question. And if the answer is that it might or it might not, then we actually can't assert that it isn't using the original context. But if false actually means use the default context, then in that case, um, we can in fact make this assertion. Um, so I want to look that up. So C sharp configure and configure await false views by custom context. I don't know who this person is, so I'm not. There we go. Let's talk to this guy. He's known a thing or two. Um, Same as configure await false. Perfectly normal, except that it will not catch the context. Assuming the await does yield, then the async method will resume executing on any available. Oh, the await does yield. So I wonder if that means so if we did like a task from result. Uh, so So well, in this situation where it never actually had to reschedule, maybe that's what that means. How about that? That's interesting to know. Okay, so but what this says is it will not capture the context, assuming that this yields um, on any available thread pool thread. Yeah, great. This is exactly the information I was looking for. So um, let's write that down because this is important. So here we know because this isn't just a result, this isn't a completed task. It actually has to wait on it to finish. Then we know that like that's the then in that case the defined behavior is actually that we will use um, a different context. Will not capture the context. Um, so we know that they should not be equal. Okay. Yeah, let's write that down. Let's grab the pointer. Um, all right. So from there, so we know that because s dot delay turns an unfinished task, um, and is therefore awaited or viewed, and therefore does yield that the context will not be captured. As a result, we can assert that the current context is not the same as the original context. Now down here, it's the opposite. Um, or rather, we just simply can't make that assertion. So we know that because task dot from result returns a finished task and therefore does not yield the uh, the context may or may not be reserved. As a result, we cannot assert anything about the current synchronization context at this point. However, because synchronization context has its own thread dedicated to it, we do know that the uh, that the continued with delegate of the rest of this method will not be running on that thread. So we can assert that the current thread is not the one by name organization. All right, now let's rerun this actually. Let's make sure that's true. If this fails, then I didn't know what I think I knew. Cool. All right, we got there. Um, so that's pretty much all this stuff does. So we can throw that away now. Let's commit. And then, so the reason I preserved this yesterday here is because we're using different types for the awaiters for the captured context, or the configured awaiters, really. And so we're probably going to have to do this same thing that we did with this copied state machine. So let's just check the code coverage. Um, I think the result is going to be that it's going to use the uh, unsafe on completed for that, and so we're going to not get 100%. We'll just have to cover a couple more things. So here, oh, 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 because I didn't even use my own custom. Okay, all I've done at this point is test the .NET task. But we do need to use this thing up here. So let's do that. Here we go. Um, and this one, so we need to add something to this to give us uh, the value with no delay. Uh, uh, yeah, so we to give value no delay. Oops, we gotta have our figure weights in here. All right, now let's rerun those tests. Okay, that's not the best. Let's also change this to or let's do the this assertion here real quick too. Um, this should cause this to fail. Good. I mean, not guaranteed, but very likely, I guess. Um, okay. Why did this fail? So we didn't preserve the context. So what happened? Task wrapper. Where's our task wrapper at? Oh, I just said always false. Okay. Yay. Hey, unit testing caught it. This is great. Love it. All right. I opened that yesterday. Okay. Okay. Uh, let's run code coverage. Let's new keyboard shortcuts. Here, tasks. Okay, we got our coverage there, and yeah, as expected, we didn't get full coverage here, so we don't have the safe on completed. So we are going to have to do this same thing here. So this, let's give these better names. Configure wait false um, with delay. Configure wait false with no delay. Okay, and then this method, we're going to want to do it for both. Um, True and false. So basically, we've got to write the same, um, these same three tests. Okay, this is going to be a little bit annoying um, to document and everything. I want to say like exactly the same. State machine slightly modified. I think I can say exactly that. So copy these. Very true. Safe on completed. Okay. And now let's copy this block comment. Give it the actual. Oh, whoops. Yeah, give it the actual code. So this is the actual code. Okay. And then this one, same deal. Uh, this little comment. Mm, and last one. Mm, and we'll just go ahead and remove these because we wanted to remove them anyway. All right. All good stuff. So now let's open up SharpLab. I don't know. It doesn't seem like it opened up. No problem. We'll just copy it. Okay. Um, great. But this time, um, we just need to change. Where's our test? Safe on. Oh, there's the test. Okay. Um, this time we just need to change that to be this. Oh, we need to throw in the mock synchronization context too. Where that went. Okay. Third static void is not null. Object. No. Okay, everything's good there. Now we need system. And compiles. Wow. All right, safe uncompleted. Let's find it. So here's the state machine, and here's the test. Okay. Copied the wrong code. Oh, it's the same code. Good. All right. Let's put that in there, and then copy the state machine. And then we gotta change this to this. So that with this state machine. How did I mess that up? This with that. Let's do it. Okay. This. This is no longer async. All right, we're getting there. Now let's call this builder. Okay. Let's call this self. Let's call this state. And then we had to remove all the nullable things. And this is same for Normalization context. This is provided value. I think what did I do up here? Did I call that value or three? Call it value. Current context. I call this S5, I think. Oh, they number they number all the variables. They count them. S5. I'm just gonna call it S5 anyway. And U1. Okay, most of the way there. So now we need some suppressions. Did I do the suppressions correctly up here? I did. Love it. All right. Let's do the turning off part first. Or the turning back on part, actually. Turning off the suppression. And what other stuff do we have? I think up here I just use exclamation points. U1. Yeah, I just use exclamation points. All right, let's use exclamation points again. Oh, current context can be nullable for sure. It is nullable. Synchronization context. Okay, let's run this. Now let's get our code coverage. Configured. Ah, right. I didn't do the whole reason we were doing all that is to call the Python completed. All right, let's do it again. Great, we got safe on completed covered. Okay. So now we actually would have 100% coverage, but we want to make sure that we actually cover 100% of it. So we're going to actually do this, the rest of this too. So let's go back over here and fix this with our lovely code. So all right, not equal worked great. Let's go down here. This is our new test code. And the stuff above it is our state machine. And let's give it the right name. This correct. It's no longer async. All right. And now we're doing the boring stuff again. Great. All right. Done. None of these are nullable. We're just doing all the same stuff. Well, actually, that attribute just simply doesn't apply. Um, now let's do the renames. Synchronization, context, divided value, value, current context. That's 5, 1. Right. Then most of these remain not nullable. Suppression. So right there. These are all forgivings. Okay. What's still? Oh, mix a couple. And then important aspect. This is now calling that. So let's do it. Run this. Passed. Good. So now let's do code coverage. Make sure we do what we expected. And now we got the safe one called. Good. All right. And back over here, let's do this last test, and then we can be done with these tests. I hope. I think we'll have 100% coverage at that point, so we can call it good. Uh, okay, I did change that, so let's get this method, pull that in. Okay, nice. So this is going to be our test body now. And then this is our state machine. And we will call this that state machine. Put this up here so our documentation is correct and we're no longer async. All right, let's get to work. All right, so this is synchronization context. All right. Got that stuff done with this attribute that we aren't allowed to use, and then let's do the expressions. And all giving operators. And we've got to call the safe variant. Run the test. Run the code coverage. Oh, right. Yeah, yeah. This one doesn't have a delay, so it's not actually ever going to get there. Cool. Uh, Now let's do code coverage on this. Make sure that we have 100% coverage on all those types. Security tests and private service tests. Good. All right. Commit. Because that is some really annoying work, I'm going to go ahead and push actually. Let's... Okay. So, how did we get here? I think we got here because we were supposed to test task wrapper. Um, so it looks itself pretty code reviewed. So close all this out then, and let's open up our new place here. Did I test? Oh, I did. I already tested these. So yeah, we're just doing task wrapper tests. So open this up and let's do our review. Okay, we got the comment line. How about the namespace? We are in the right namespace using statements. This is supposed to come after. And then a sealed class. Actually, a couple things. So this is also sealed. This is also sealed. Compiler generated won't count actually, but okay, so we sealed everything. And now in these other classes, let's check if we did all the right stuff. So we should have read-only fields, good. We should have precondition checks. You know, you're allowed to give me a null here. And the rest of these don't have any parameters. This dot Didn't do it everywhere. This dot, uh, this will tell you that, okay, cool. Um, oh, I have to search for to-dos. Caught exceptions, catch. That's compiler generated, compiler generated, compiler generated, compiler generated. But they did give it meaningful names, so that's cool. Um, Interesting. Let's go to the next class. So this read-only fields, nailed it. Precondition checks. Hmm. I don't know. Oh, I didn't. I'm all over the place right now. Here. Now we need to do exception documentation. No exceptions from that. This. Can there be exceptions from this? Even out of range exception. 100 is not out of range. So we're good on this. Because we're good on that, then we are good on this. And this one, can this throw? It cannot. Okay. All right. Now let's go to our next class. This one, preconditions. Okay. I don't know about this, so I need to look it up. Chart synchronization, context. Okay. And what stuff should we implement? Send and post. This. I kind of don't believe it's not going to throw. What does it mean if this is null? Is that just a no op then? Maybe. Let's see what this code has to say about the matter. That's not helpful. Okay. Base dot post. Pull Q user. Never seen this before. Static S. Does Q user work item throw? Well, it just took us here. Uh, so which one's being called? This is the one that takes the action. Okay. Ah, so what? True if it's successful, exception if not. What's the true for then? Okay. If the work item could not be queued. Well, let's look at the source then, because this is bonkers. Uh, oh, and it's an argument null exception. All right, love it. Okay. Uh, Uh, all right, let's start making some notes. Argument null exception if callback is null. Yeah, and then I don't know when the not supported exception comes in. Uh, wow, 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 wow. Red pool work queue. All right, well let's look in here. In queue. Oh man, it's gonna be impossible to find this not supported exception. Well, so let's back up. So we don't worry about the not supported exception. We were questioning the argument null exception. And we have now confirmed that despite not being documented, this does throw argument null exception. And as a result, this will throw an argument null exception, just also despite not being documented. Oh, well, this is send. Let me go back to post. Um, okay, despite also not being documented. Um, argument null exception is the null. Okay, and then let's look at send. Um, so paste dot send. Oh, it just does it immediately. Oh, neat, 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 neat. Terrible. It's gonna be a null reference, right? Uh, synchronization context dot send. Null, null. Uh, yeah, I don't care. Why didn't it run the test? Reference. Wow, 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 wow. All right, well, all right. So we know the behavior now. I'm going to file these as bugs at some later time. Is my game plan. But now, since we know the behavior, we can. I always struggle with this. We'll preserve behavior. So we won't throw for send, but we will throw for post. Okay, we did our diligence now. That's the precondition check. Um, so now exception documentation. Don't have any exceptions there. We don't have any exceptions there. This is inherit doc. This is inherit doc. And here, what do we have? Can this throw? Nope. Can this throw? Nope. And ooh, what if the callback throws? What does that mean? Huh. Oh, wow, this might actually be. Oh no, these are self-contained. So, like, if I was sharing the synchronization context between tests, then one test that fails is going to actually cause all the other ones to not run. Um, I I truly don't know what you're supposed to do here. If I'm supposed to catch this or what. It's like actually let's try something. So uh, try catch. So now let's just assert fail here, and let's see what happens. So it did fail. I actually don't understand why. It's like oh, maybe these are wrapped. Yeah, oh, that's why I'm gonna guess that these are wrapped. Yeah, let's check out this compiled code actually. So this is um this thing. Oh wait, uncompleted. So in here it's gonna do something, I don't know. But at some point it's gonna call uncompleted state machine box. Move next action. So I think state machine box move next action. Um, so let's actually look at our move next. Um, this is a move next. Great. And this, yeah, has this wonderful catch here. And then it sets the result. Okay, so these can never throw. Um, okay, so what does it mean in the context of like a full synchronization context? I'm getting close to time here, so I'm going to put it to do. Um, state machines wrap the delegates in a catch so they will never pass callbacks that throw exceptions. However, in the context of from the paradigm of a general synchronization. That's someone could give us a callback that throws. How do we want to handle this? Yeah, because that's my question. So if like if I just initialize one of these and start sending and posting stuff, um, yeah, my question is basically what do we do then? Because those could throw. If that throws, then we do stop processing, and that would actually mess up the state machines that are built from async await. And so um, we likely need to catch them, and the caller's already lost contact, like they or lost the frame of reference. I think we just have to catch it and nothing happens with it. Um, I don't know. I'll think about it some more and we will come back to this tomorrow. But let me commit. Let me also note where I'm at. So here, exception, documentation, free text code review, code review of the test. Um, Once this class is done, we should move on to use for the whole file. All right, and committed. Now I'm going to push. And that's all for today.